Hi, I'm Sarah from HoRNet Plugins, and I'm about to show you our latest plugin, which is called Planner. We made this plugin because we felt we need to make a high-quality clipper that was not compromising with quality and flexibility. So what we did was take a very simple algorithm with variable thresholds and variable knee, and converting it to a clipper with very high oversampling options that brings the aliasing distortion down to negative 150 dBs. So it's a very simple plugin, it's a very single algorithm. It doesn't anything magic, but it does it very well. So for this demonstration, I'm going to start with some technical details before diving into Plugin Doctor to let you see how a clipper works exactly. Then I'll let you hear some sound samples. So let's jump right in. So this is the UI of the plugin, and it's already inside Plugin Doctor, so you can see it working already. It's in its default configuration, so you don't have any gain on the inputs and any gain on the output. We are feeding it with a 12 almost 12 dB level signal, so it's very much above the 0 dB threshold we're having right now for the ceiling. So we are clipping everything, and we are clipping it very hard because we have 0 dB of knee. You don't see the ceiling here because the limit is the 0 dB, which is 1 in digital audio. You have a different option for the clipper shape for the positive half wave and the negative half wave. So you can have asymmetrical clippers that are very interesting. Add some more harmonics to the signal, making it more fat. Then you have, of course, the option to set your input level and output level, link them so when you rise one, the other one goes down, and the opposite is true too. Let's bring everything back to 0. You have the famous oversample option, which is now set to auto, which guarantee good performance with a very good sound, and it changes oversampling not just between these options, but continuously changing that according to your sample rate to always give us enough bandwidth to sound good without using too much CPU. Then, moving to the right, we have the knee controls, which allows you to set the sharpness of the transition, and I'll let you see later how it works. And of course, you can link them both for the ceiling and the knee, so everything changes symmetrically, or you can do it asymmetrically. And then you have our gain reduction meter that shows you the amount of dB that are being shaved off from your signal thanks to the clipping. It goes down to negative 12, which is a lot in clipping realm. So it shows almost full now because we are up above 20 dBs. So the output meters, and then you have the delta mode, which will let you hear only the differences between the original signal and the processes one, and of course our bypass switch that completely bypasses the process. So now the first thing I'm going to show you is that with the auto oversample mode, you get the right amount of aliasing without sacrificing CPU usage. We are feeding the plugin with 1 kilohertz, almost 1 kilohertz signal, which is our line over here, and theoretically we shouldn't have any signal below this one because this is our fundamental, and we shouldn't have any signal. Anything we find down here is aliasing distortion, and it shouldn't exist. So now we are in auto oversample. I don't know the actual amount of oversampling, probably 32. And the maximum aliasing we have is at negative 110 dBs, which is very low, but still not that clean. If, for example, I disable oversampling overall, this is what cheap clippers and distortion unit does, we are almost not using CPU, It's very light now, but look over here. We have aliasing at negative 45 dBs, so it's very noisy with a lot of distortion. And see how many little spikes we have over here. This means that this is an inharmonical distortion that never sounds good. But if you want the maximum quality available in this plugin, just stick with this massive 256 times oversampling. We can have this amount of oversampling because the algorithm is very simple, very light, so we can use a high level of oversampling to get the aliasing down to almost nothing. Have a look here. And it goes down to negative, this peak is negative 125, and overall we are almost below this line, which is the line at which is possible to record signal with 24 bits depth of audio. So everything below this line cannot be reproduced by converters. So see how just a few peaks we have here, and this means that the clipper is now very clean. And if I close the UI, you can see the harmonics profile. We are having only even harmonics, so first, third, fifth, and so on. And now, what happens if I enable the asymmetric clipping? For example, if I take the positive part of the signal and okay, let me reduce the UI so we can see more easily the harmonic response. Okay, so here we are. So if I, for example, take this slider here and say I want to clip the positive half at negative 4 dBs, you see that we're starting seeing the second order harmonics and fourth and the sixth and so on. We are adding other kind of harmonics that makes the sound warmer, more in the kind of a tube sound. The same thing we can do with the lower half, the negative half. So as long as you are not having the same values, you are adding different kind of harmonics, second order and so on. So it's up to you to decide how many and how to add those harmonics. And you can also have, of course, a soft clipper style. So with these knees, with these sliders, you adjust the knee of the transfer function, make it more softer or harder. And of course, you can have two different knees for this positive and negative part of the wave. This is not that clear on this graph because you only see these harmonics being added. But if you go to the oscilloscope view and you go down to 20 Hz, so we can see something, you can see that we are now clipping the signal. These straight lines means that the signal is clipped. But if I increase the ceiling here and here, and reduce maybe the level to something that we can see. Okay, so I'll just reduce the ceiling so we can see something. You see, we don't have the straight lines unless I go to 0 with the knee. Then our straight lines are back. And if I add some knee, you start to get a more rounded shape, which means that the clipping is softer. The level is reduced, as you can see, so it's being clipped, but in a much softer way. So you have different harmonic content and different sound. This is very, very handy to shape the sound, not just to clip your final mixes. So now that I show you the technical side of our plugin, of HoRNet Planner, I can let you hear how it sounds. Let's jump back into the DAW. Okay, here we are into our DAW, which is Reaper. I have prepared a kick loop to let you hear how Planner affects a kick drum, which is, of course, has a very audible distortion when clipped, so it's a good candidate for demonstration. And then I'll let you hear a short part of a complete mix and see how Planner can be used to get more loudness out of a mix. So the first thing is this is the kick drum, and you can hear it's a standard electronic kick. Then, without touching input and output, I will adjust the ceiling so that I get a little bit of distortion with hard clipping. Let's use the delta function to hear what the plugin is doing. Okay, so now here we got a little bit of distortion, and then I will adjust the knee to make it more prominent and get the sound I want. So if I want a little bit more of distortion, and this is a nice transistor saturated kick. And here the difference if I disable the oversampling versus the auto one. Can you hear it's a little bit cleaner and it's better than the none option? And if I go with a hard knee, things becomes more noticeable. So this is none, and this is auto. The bass is a little bit more stable, more present, because we are reducing the inharmonic content. And now let's bring everything back and see if we can generate a more interesting sound using an asymmetrical kind of clipping. So it's an interesting tone shaping tool, as you can hear. So we are now creating second order, fourth order, and so on harmonics, and the sound is a little bit more warmer than with a symmetrical clipping and distortion. Can you hear that? So this is what you can do with sound design, but if I bring everything back to its default, I can use the input and output sliders to get more loudness out of my tracks. Now I use this other loop here, it's at the part of the song, and I will simply disable the link IO, otherwise I will get an increased loudness because of the output gain going down, and then I'll try to squeeze more loudness from this track. This is what we are removing from the track. You see this little distortion, and we got much louder. And this level we have achieved without sacrificing any quality in the signal, because we are using a very high level of oversampling, so we are not introducing aliasing at all. So this was HoRNet Planer, and it's our new plugin. It's available right now on our website, www.hornetplugins.com. We have a demo, so you can go there, download the demo, try it out for yourself, and if you like it, you can buy it. It's just €8.99. For this kind of quality, it's a bargain. So just let us know if you like the plugin in the comments here on YouTube or through our social networks, whatever. So we are here, we are open to suggestion, and thank you very much for watching the video.